Okay, Mr. Hunt here with volume of pyramids and cones. Here's what I want you to do first. We're going to figure out the volume formula for a pyramid. Notice that in this box there's several prisms, and inside is a pyramid. Okay, it's fitting in to each of the prisms. Calculate the volume of each prism, and then I've given you the volume of the pyramid, and I want you to compare. So go ahead and calculate the volume of each pyramid. Feel free to pause the video here. Sorry, volume of each prism. Okay, so let's come back here. So what you should have found, let's see this first one, upper left, 1 times 1 times 1 is 1. This middle one, 2 times 2 times 3 for 12. This bottom left one here, 1 times 1 times 3 is 3. These are all rectangular prisms, so it's just length times width times height. This one was 1 times 2 times 3, 6. And this one down here, the prism is 1 times 3 times 6, 18. Now, how does that compare with the given volume of the pyramid? That fits, the pyramid fits perfectly inside. The height reaches to the top there. Well, this one's 1/3, and this one's 4, and this one's 1, 2 over here, and 6 over here. So, how does it compare? Well, the volume of each pyramid is the prism divided by 3. We like to this, the volume is 1/3. So the capital B times H, that's the same as a prism, just 1/3. Okay. Now, same thing for this is for pyramid. Same thing for the volume of a cone, right? That's why we do these in pairs. It's 1/3 capital B times H, but the capital B is a circle. So there's the two formulas you can write down. Okay. The other thing I want to say here, I have a nice slide in my notes about this, but it can be hard to see this, but really, especially for the cone, if I took a cone and a cylinder and they had the exact same dimensions, okay, same diameter, same height, right, they're both the same. Here's what you could do. I mean, you could really, I have this nice little diagram in class I could show you, but it just, if you fill this up, put some water in here, fill it up with some rice or something that would fill the entire thing, not have gaps. If you pour it into here, it's going to fit exactly 3 times. All right? That's how it works. All right, so let's try some examples. Feel free to, pause the video as we go along with all these here. So the first one, part A, I have pyramid. Actually, all the first ones are pyramids. Let's see, this is supposed to be a dotted line there, and so is this. They kind of got a little bit off here. 14, 14. So this is a square pyramid. Now, we need the volume. Okay, pretty simple. 1/3 capital B times H. All right, great. Well, capital B, I like to do it off to the side. It's a square. 14 times 14. So that's 16. What's the height? It is not 25. Notice they've given you the slant height of 25. Because you're either going to have to find the height or find the slant height for the surface area and volume of a pyramid. So if I say find both, you're going to have to do Pythagorean theorem at least once. You drop in this right angle here. That should go straight down. Sorry about that. And you've got a triangle with 25, H here. What is the base? Well, since it's a square, it's half of 14. We haven't gone all the way over. It's 7. We do some Pythagorean theorem. You get 24. Okay. Oh, sorry. I meant 196 here. My bad. So 24, if you do Pythagorean theorem. It's also a Pythagorean triple. And sorry, 14 times 14, 196. I forgot the 9. So what is that? 1568 centimeters cubed. Okay, I'm going to jump right into the next one. Feel free to pause. B. So let me draw that. Hopefully that's decent enough. 9 millimeters is that height, and 6 is that length at the base of the triangle. Well, okay. pyramid, 1/3 capital B times H. Capital B, look at this, it's another, I say in the problem, these are regular pyramids. That means that the base is a regular polygon. So this is a regular triangle, so they're actually all 6. This is 6, right, all of that. So then we drop in a height. I mean, you can probably guess by now it's the radical 3 one. So this is radical 3. It's radical 3. So the height is going to be 3 radical 3. The height of the triangle. So let's do it down here. Capital B is a triangle, 1/2 base times height, half of 6, not 3, and then height 3 radical 3. So we're going to get 9 radical 3. Should look familiar to one we did the other day. Then the height is 9. Okay, this h is height of the pyramid. So I do 1/3 times 9 times 9, I get 27, and then I'll leave the radical 3 there. Cubic millimeters. All right, last one for a pyramid, and then I think we got 2 cone ones. So let's do. See, this is a good one to do. I showed us one of these the first day with prisms and cylinders. So it's a regular figure, so it's a regular pentagon. So the volume for a pyramid, 1/3 capital B times H. Let's go ahead and fill in, we need capital B, but we know that height is 10. I'm not going to draw it in, but the height of the prism is 10. So the goal is find capital B. This is where it's a regular figure. If it's not a triangle or square, we know those area formulas, then you're going to have to break it up into triangles. All right, so check this out. It's a pentagon. It's always going to be the number of sides, that many triangles. So I've got 1 triangle there, right? You see the base there? It is 5 triangles. Congruent triangles that I can break it up to. So I'm going to find the area of 1 triangle and multiply by 5. Okay. Well, the area of 1 triangle, so let's do, well, it's a triangle. I'm going to get this and multiply by 5. It's half. I'll make a note to myself, times 5. Half. Well, the base is, let's see here, 6, right? So if we want the area of 1 triangle, right, I need this height. It's going to be 1/2 that base, okay, which is 6, times this height. Now that height, we don't have much other information to go on. Here's what we got to do. It's not 30, 60, 90, it's not 44, 45, 45, 90. I'm going to find that angle. On the inside here, there's 360 degrees totaling, right, once around, totaling all 5 of those angles. Well, if they're all congruent, I can just take 360, divide by 5, and I'll get 72 for this angle. Excuse me, let me make one adjustment to that. 72 is actually, I'm going to say, it's this whole angle, right, all the way across there. And we just want half of that. So then I take that 72 and divide it by 2. So this angle is 36. Now I got to do trig. I'll call it H there. And let's see, I know that this is 3. So I can do tangent of 36 equals opposite 3 over adjacent H. Okay? I do the old switcheroo with these. H is going to be 3 over tangent 36. Make sure you're in degree mode. All right, and when you put that in, it's going to be about 4.13. All right, so that is what I put in up here, 4.13. That's the height of my triangle. And now I'm just going to put it in my calculator. Okay, when I do 1/2 times 6 times 4.13, I get about 4.129. That's the area of this triangle right there. For the whole thing, though, well, just multiply by 5. Let's go with that. Multiply by 5. And you should get about 20.64 6. Usually 3 decimal places is good. Okay, sorry, I just realized something. I'm going to have to go back here. It's not easy to go back on these. Sorry, I just entered this in wrong. I was looking at another number. Half times 6 times this 4.13 about from down here. It is going to be 12.387. Sorry. Then times 5. This looks better. And so we get about 61.937. Okay, and that goes over here. That is the base area because we multiplied 61 point. We multiplied the area of the triangle. This times 5, so that's the pentagon. Put it in over here. About 206.5 cubic centimeters. Okay, sorry about that. Feel free to go back and correct. I'm going to finish up the last 2 examples. Okay, now let's look at some cones. So on this one, on A, volume 1/3 pi r squared h. Okay, what do we have here? We are given the height, so that's good. Don't have the radius. The height is right here, though. It's 15. This is just another one where, well, we're given the height. Let's see if I can draw it. We're given that and this, and we're asked to find, there is a right angle, good. We're asked to find, we need the radius. Well, there's a triangle that's formed, and we got a right triangle. This is 15, this is 17, and I'll call it B. And we can do some Pythagorean theorem. It's 15. Okay, now when you do, it's also Pythagorean triple, 8, 15, 17. Not the most common one, but certainly one of them. Do Pythagorean theorem, you're going to get 8. So, all right, let's leave this one in terms of pi as well. So here's what I entered in my calculator, right? I do 1/3 times 8 squared times 15. Feel free to do those separately if you want as well. 320 pi. What do we got? Cubic centimeters. Oh, yeah. Sorry. The 17 is supposed to have a centimeters on it, not meters. Okay. Good for your pop one. So on B, read through it there. We got the circumference of the base of the cone-shaped pile of sawdust is 50 feet. That's the circumference. Okay. To the nearest, we got an angle, right? An angle of elevation of 40. To the nearest tenth of a foot, how tall is the pile? So they're asking for the height. Okay. So really what they want, right angle, that's 40, sorry, I'm a little blurred. What they want is just this height right there. I'll call it h. Well, we have that angle, but without another side, we can't do much. But what we can do is we can figure out the radius. How do we do that? Well, the circumference is 2 pi r, and they give it to us as 50. So one of those plug in what you know, solve for what you need. Hey, this should remind us of circles. We had problems like this. Divide both sides by 2 pi. Okay. Feel free to enter these in your calculator separately. 50 divided by 2 divided by pi. Or just make sure to use parentheses. Okay. And when you do, you should get about, just want to make sure here, 7.958. Again, thousandths if you have to. Don't round too early at all. So that's the radius. Now, how do we get the height? Well, we don't have. If we had the volume, wow, we could plug in the volume formula. Be good. But we don't, so we're going to have to do. Well, we got. This is about 7.958. We can do trig. Do some trig again. Very important to remember. So I want to make sure we're still practicing it. Tangent of 40, opposite h over adjacent to 7.958. Variable up high, multiply. Oh, I'm doing it wrong. Variable up high, multiply both sides by the 7.958. Right. Variable down low, switch a row. Variable up high, multiply. I forgot to say that in the last one. Okay, and you do, and you get about 6.68 for the height. Sounds good? I'm going to end it right there. Thanks for watching.